Hello, class. This week we talked about measures of variation, and one of the things that we'll be using a lot is standard deviation. So I'm going to walk through an example doing it somewhat manually, as well as using what Excel has to offer to make it a little bit easier. So here is our data. This list of numbers right here, 4, 5, 6, 7, 8, 8, 10, 11, 13. That is our x value. I'm just going to count those 2, 3, 4, 5, 6, 7, 8. So we have 9 numbers. Remember, n always is our sample size. So I'm just going to make a note that n equals 9. Okay, so to calculate a standard deviation, you need to have your mean because we're going to calculate a deviation, and that is just our x value minus our mean. So we can calculate our mean here by summing up these numbers and then dividing by 9. So I'm going to use that sum, which we looked at a previous video, that sum function right here. I'm going to double click on that and just select those numbers and then just hit enter. And so the sum of these numbers is 72. So I can calculate the mean. Remember, start with an equal. Now I could just type in 72 divided by 9, or I can point to that 72. And it populates this right here with the cell location, I-14. And I'm going to divide that by 9. So my mean in this example is 8. Or I could use, if you remember, that average formula. I always start with an equal sign. I'm going to start typing it in. It comes up for me. Double click on it. I'm just going to highlight my numbers and hit enter. And as you can see, our average, our mean is 8. So to calculate a standard deviation, you subtract your mean from each of your x values. So I'm going to start here. I'm going to start with an equal sign. And I'm going to point to where my x value is. So one cell to the left. And then I'm going to subtract my mean, which happens to be 8. And now, since I have that formula there, I can just copy that formula down to the rest of the cells. Because remember, Excel is going to automatically adjust the location where we're looking to be one cell to the left. You can see here, it's looking at I7 minus 8, which is I, and now we're on the 7th row. You can't see it, but it's 7. So if I were to look, if you look up here, as I walk down the rows, you'll see that that location of where the x value is has adjusted accordingly. So these are our deviations from the mean. And if you recall, the next thing you do is you square that so that you get rid of your negative numbers. So we're going to say equal. And there's a couple of ways I can do it. I think for me the easiest is to just go over here and point there. And then I'm just going to multiply it by itself. So I've got J5, and I'm going to multiply, and I'm going to point to it again and hit enter. That's the same thing as squaring that. I'm just multiplying -4 times -4. I'm going to copy that down to all these rows. And now I just have -3 squared is 9, -2 is 4, and as you can see, all the way down. Sorry. This SS stands for the sum of the squares, and that's the next step in calculating your standard deviation, is that you add up this column. So again, I'm going to use this sum formula, and I'm just going to highlight these and hit enter. So I've summed up my squares. The next step is to divide by n if it's a population. If it's a sample, we subtract 1 from n, but let's assume for the moment that this is a population. And so I'm going to take my 68, I'm just going to point to it, and I'm going to divide by 9 because that's my sample size, and I'm assuming it's a population, and I get 7.56. This is my variance. That is not my standard deviation. Our next step is going to give us our standard deviation. The variance is the sum of the squares divided by your sample size or your population size. And the next step is to take the square root of that whole thing, and that will be our standard deviation. So there is a formula in Excel called SQRT, which is shortcut for square root. So I'm just going to start typing it in. And as you can see, there's your SQRT. I'm going to double click on that. And I'm just telling it that I want the square root of the number above it. Hit enter, and my standard deviation is 2.75. So that was a lot of work to get to this standard deviation. But luckily, in Excel, there is a standard deviation formula. And that formula is equal, I'm going to start typing ST, and you'll see right here, STDEV.P and STDEV.S. You might be able to guess what that P and that S stand for. P is population and S is sample. So for the moment, we assume that this was a population. So I'm going to select that. I'm going to highlight these numbers that I want the standard deviation of and hit enter. And as you can see, I got my 2.75. I just haven't told it that I just want 2 decimal places here. So a nice quick way, as you can see up here, here's my formula. And down here we have our result, which is 2.75, which is what we came up with doing it manually. Now, what if instead of it being a population, it was a sample? The only thing different we would do, all of this is the same. We sum up our squares. The only difference is when we get to our variance, instead of dividing by, if you look up here, instead of dividing by 9, we divide by 9 minus 1. So this 9 minus 9 in the denominator becomes an 8. That becomes a variance. My standard deviation automatically updated because I'm just taking the square root of the whatever's in the cell above it, which is at K15. And so my standard deviation for a sample is 2.92. And we can do it very easily by selecting STDEV.S. Select these numbers, and there it is. 2.915, which is 2.92. Now this was the population, this was the sample. As you can see, the standard deviation for a sample is for the same data set, for the same data. The standard deviation for a sample is going to be larger than the standard deviation for a population. We're actually forcing it to be larger by dividing by a smaller number. We subtract that 1 from the 9, from the sample size. We subtract a 1 when it's a sample, forcing the standard deviation to be larger. It's almost like we are accounting for the fact that there's something we don't know. If you remember, a population is everybody that you care about. So if I cared about the ages of all you students in my class, and that was my goal, just to have a standard deviation of the students in this class, I could ask every single one of you what your age is, and I could figure out a population standard deviation, and my number would be spot on because I have all of the data. But if I wanted that information and I only asked 10 of you out of 27 what your ages were, in other words, I just took a nice little sample, I would have to account for the fact that there's something I don't know. There are ages I don't know about. So I'm kind of artificially forcing my standard deviation to be a little bit larger to account for the fact that I don't have all my data. So we're just kind of erring on the side of caution. So we just, I just want to, hold on one second. Just going to bring this over here. So these are the formulas that we use just doing this. If we used STDEV.P or S, we don't have to do any of this other math that we did over here. We can just use this and come up with our standard deviation. If we're going to be doing the math ourselves, we can still take advantage of this sum formula, and we can take advantage of this average formula to calculate the mean for us. So just a few more things you can do in Excel, and when you get to that hotel project, I think you're going to want to take advantage of some of the tools that we have available to us. Okay, that's it for now. Have a good week, and please reach out sooner rather than later if you're having any concerns or problems getting through this material. Okay.